Look at areas of parallelograms. It's going to help us to remember what the area for a rectangle is. Remember, area is what's inside the figure. The formula for the area of a rectangle is length times width. Area is equal to length times width. So the length of our rectangle here is 15, and our width is 10. Sometimes referred to as the length and the height. So it's 15 times 10, which equals 150, and we're going to label it, we'll label it square centimeters. So the area, or what's inside here, is in square centimeters. Now the thing with a rectangle is that these are right angles, and this width can also be called the height because of this right angle. Alright, so we have a parallelogram. It is a quadrilateral, meaning it does have 4 sides. Opposite sides are congruent and parallel. So if that base of that parallelogram is already 5, this opposite side is not only parallel, but it must be the same length. This looks like it's less than 5. It's probably 4. I'm just going to label it, just so that we have another label within that parallelogram. Remember, opposite sides must be equal as well. Now the other thing that is on this slide, it says a rectangle is a type of parallelogram, except parallelograms do not necessarily have to have right angles. That's why we're going to need this height for this parallelogram, and so we'll use that to figure out area. Let's look at the formula for that height and times the base to equal that area for the parallelogram. It'll be on the next screen. Okay, so for the area of a parallelogram, the formula is area is equal to base times height. Now it's pretty clear within this picture here that the base would be 5 and the height would be 3. Any side of a parallelogram, though, can be considered a base, and the height of a parallelogram is the perpendicular distance between opposite bases. And then so what this means is this. I'm going to redraw that parallelogram just to show you. After they figured it out, this is area space times height. Area is equal to 5 times 3. Area is equal to 15 square meters. It really should look like this with that as an exponent. Now, let me redraw that parallelogram. So, really we could have drawn it this way as well, whereas whatever measurement this is times whatever measurement this is here should also equal 15. Should also equal 15. It's possible that this might have been 3 and this might have been 5, so that 3 times 5 equals 15. So it's the perpendicular distance if we had considered this to be a base instead, where that area is equal to base times height. This base here, 3, times this height here, perpendicular to the opposite base, which equals 15, and I believe it was square meters from before. Let's look at a few more examples. For this example, we have area is equal to base times height. And then so they have 25 times 10. This here is the base of the parallelogram, and the height is labeled as 10 feet. 25 times 10 is 300, and it's 300 square feet. Let me just cross out this label and just write it out. Square feet. Okay, you go ahead and try one. Go ahead and copy it down. Write out that formula. Area is equal to base times height. And show me that work. Be sure to label it carefully. Hit pause. Okay, base is 9 inches. And what do you use for the height? Remember, it's the perpendicular distance between the opposite base. And then so that you would use that 4. 9 times 4 is equal to 36. And did you label it correctly? Did you label it square inches? The area of this parallelogram is 36 square inches. Alright, here's another example. Base times height equaling that area for the parallelogram. And then so in this case, we actually have a base. Can't use 22 because we don't have a perpendicular distance that's labeled. We can use 25 though, because this perpendicular distance is labeled back to the opposite base. So we'll use 25 as our base and 20 as our height. Now really, if I just taken this here and the picture and just rotated it to the way that it was and looked in the other examples that we've seen thus far, it would have been the same way. Since they don't have a label for us, we're going to go ahead and just label it units, and in fact we'll label it square units. So this would have been 25 units times 20 units, and that's why we get 500 square units for the area. Remember, you must show your work. In reviewing, hey, remember that formula. So it's similar to area is equal to length times width for a rectangle. However, with the case of a parallelogram, does not necessarily have to have right angles. The other thing that this says here is that you have to show your work. You have to show your work. So if this was 6 and this was 3 and this happened to be, I don't know, say 2, then you would have to show your work. That is, area is equal to 6 times 2 equals 12 square units. One last little example here. If the base is 15 and the height is 4 inches for a parallelogram, I always like to draw it out. So if this was 15 here, then perpendicular distance would be 4. And then so you end up having a parallelogram there. What's the area? So in that case, I'll use a different color here. Area is equal to 15, and these are inches now, times 4, which equals 60. And then lastly, don't lose points on the label. It would be 60 what? Square inches. And you can write it out that way. So that's your area for parallelograms.